Alright, this is just a short little addendum I made to explain vectors and the math behind them. This is really useful to actually understand, and while we're not going to go into crazy detail, we're going to look at a few things so that you hopefully can grasp the basic concept of vectors. So first we're going to start with something everyone should be familiar with, the number line. Now as you can see, the line goes from 0 to 5, and of course beyond that as well. But for our purposes, this is all we need. You could imagine yourself being somewhere on that line. To know your location, you would only need to know one number, the number you're standing on, right? So this would be a one-dimensional line in this case, because only one number is needed to know where you are. Let's add the negative numbers as well. Is this still one-dimensional? Yes it is, because we still only need to specify one number to know where we are. It can be negative or positive, but it's still only one number. What does this have to do with vectors, you might ask? Well, we can represent that number as a vector. So the 2 then becomes an arrow from 0 to 2. 0 in this case, and often in other cases, is called the origin. We can have different vectors. Let's see some examples here. Here we have a vector with value 2, value 3, and value negative 3. If I now were to ask you to add the numbers 2 and 3 together, you'd say, well, it's 5. But let's see what happens when we add the vectors together. Here we have a vector with value 2, and here with value 3. How can we add them together? We could imagine the vector with value 3 traveling down the first vector. And after it's made that journey, look where we end up, at 5. So 2 plus 3 equals 5. The same thing can be done with subtraction, or rather negative numbers and vectors. So 5 plus minus 3 is equal to 2. This might seem completely obvious to you, because this is how you add and subtract numbers every day. But what if we go one dimension higher, into the second dimension? Now we have two number lines. This one is traditionally called the y-axis and points upwards and is vertical. The other one is called the x-axis and is pointing to the right and is horizontal. Looking at the same example we had before, the 2 would now be written as 2, 0. Because now we need two numbers to identify where we are on this grid. We go 2 steps into the x direction and 0 steps into the y direction. But let's say we want to end up here. Well, we need to go 5 steps into the x direction and 3 steps into the y direction. We are going to call this vector a equals 5, 3 with value 5, 3. Now we might want to add another vector on this, possibly b equals minus 2 and 2. We can take exactly the same trick before. By simply sliding b along vector a, we can get to our destination. C equals 3, 5. And as you can see now, the addition and subtraction is simply an addition for each number of the vector independent of each other. So if we take the x value and add or subtract them, and if we take the y values and add or subtract them, whatever is the sum, those are the new values of the new vector. Multiplication is just stretching the vector. So if we have 2, 3 here and we multiply it by 2, then we just stretch the vector so it becomes 4, 6. And division just makes it shorter. Now for our purposes, we'll actually be using vectors in 3 dimensions, but it is just as easy as in 2 dimensions. Thank you for listening to this lecture on vectors. I believe it is an important part of mathematics to understand, especially when trying to develop a game, no matter what engine or system you're using. And if there are any questions, of course, always feel free to ask, and I'll be sure to respond. And yeah.